Hello everyone. This is the second part to the lecture section on chain rules. So I'm going to once again go about the definition of a chain rule and then talk about some specific examples in this video. So remember when we say we have a composite function, and how do we differentiate a composite function? So if of y is a differentiable function of u and u further is a differentiable function of x, then y, which is a composite of two functions f and g, is a differentiable function of x, and it is given by dy by dx equals dy by du times du by dx. Or we can write this as ddx of f of g of x as f prime evaluated at g of x times g prime of x. Okay, now we can also think this chain rule as a, inner parts and outer parts. Okay, so let's look at that scenario too. So when we're applying the chain rule, it is helpful to think of the composite function as having two parts, an inner part and an outer part. The outer part is given by f and the inner part is given by g. So the derivative of this y is the derivative of the outer function, defined at the inner function u, times the derivative of the inner function. In our first session on this chain rule, we also talked about different functions where we looked at the inner and the outer functions. In the first part of that video, I did examples for these. We looked at these functions. We did these problems, but we have yet to look at the problem of this, y equals sine of 7x. This is a classic example where we will be applying the inner and the outer function idea to find the differentials. Also remember, when we did these four problems, we had applied called the general power rule. You remember that. Let me go over the general power rule with you too. So what is the general power rule? The general power rule says if y is a function of u, which is a function of x to the power n. Now this u is a differentiable function of x and n is a rational number, then the differential of y, which is differential of u to the power n, is n times u to the power n minus 1 times u prime. So we notice that the general power rule is a special case of a chain rule. And those four examples here, the x squared plus 1, 1 over x plus 1, or sine squared x, or square root functions, these are examples where we applied the general power rule. But now we're going to learn examples of the kind where we will be applying the inner and the outer functions, and also do some other specific examples related to chain rules. Where we'll be combining it with power rules or quotient rules. We will be doing all those things. Okay, so let's start with the differential of this y equals sine of 7x. Now, notice the inner function is 7 and the outer function is sine. So for these kind of functions, when you have to take the derivative, so you will be doing the derivative of the outer function, which is f, and the inner function is u. So you write the derivative of y as f prime of u times u prime. So what is f prime of u? Remember, f of u is sine of u. So sine u prime times 7x prime, because that is the inner function, 7x. Now we know the differential of sine u is cosine u, and the differential of 7x is 7. And then remember, u has been written as in terms of 7x. It's a function, differentiable function of 7x. So you have to replace the u by x, because your original problem, remember, is in x. So you have to write down the final answer also in terms of x's. So the final answer is going to be cosine 7x times 7. Nice to make it much more nicer. to have all the numbers in the front. So we get the 7 in the front and write cosine 7x. Notice one thing, I'm very specific of how I write my 7x next to cosine. I'm putting it in parentheses. The reason is this 7x is an argument to the cosine function. Okay, let's look at a little bit more difficult examples. The first function y is cosine of x squared. Now, very similar to the sine, but here the argument is an x squared. And the outside function is cosine. So remember, your u is x squared and your f of u, which is the outside function, is cosine u. Or, so f prime of u and cosine u is the same as saying cosine x squared. So when I take the derivative of this y, which is f prime of u, which is cosine x squared the whole prime, times x squared. So the derivative of cosine x squared is what? Now remember, this is negative sine x squared. You're looking at the derivative of the outside function evaluated at x squared. Okay? So that means if I take f prime of u, I'm writing negative sine u. Now remember, u is x squared, so it is negative sine x squared. Okay? Now, so negative sine x squared times differential of x squared, which is 2x. So get the 2x in the front, negative in the very front. So you have final answer of this derivative of y of cosine x squared to be negative 2x sine x squared. Let's look at the next problem. Y equals tangent square root x minus 1. So clearly, the tangent function is the outside function. The inner function is square root x minus 1. So my u is square root x minus 1 and my f of u is tangent u. So if I take f prime of u, what is f prime of u? It is secant square u. And then we replace the u by, because the whole expression has to be in x, which is secant square root x minus 1. So here I have kind of, if once you keep practicing, you'll be able to see why you just have to write, you take the differential of tangent square root x minus 1 and then differential of inside. So it is secant square root of x minus 1 times the differential of square root x minus 1. So hopefully guys, you already know square root of x, differential of this is what? This is x to the power half. It's half x1 minus half, which is negative half, which is half, and you can write this as this, or you can let it be like this, doesn't matter. So remember, the secant square root x minus 1 times half x to the power minus half. To make it much more nicer looking in terms of mathematics, get this expression in the front and write secant square root x minus 1. So if you want to write it much more nicer looking, you don't want x with a negative exponent, and if it is a half, you can write like this. Secant square root x minus 1. Okay, now these were practice of applying the inner and the outer rules to our chain rule function, functions here, chain rule on the function, sorry. Now let's look at chain rule with other rules. Now here, we are having two functions, x squared times secant 3x. Now that means, first of all, this function is going to apply the product rule. This is the first function, second function. And then later on, when we take the differential of the second function, you can already see it's going to have a chain rule. So let's go ahead. So the first thing, this one is the product rule. So you're taking the derivative of the first function times the second function plus the first function times the derivative of the second function. So x squared differential is 2x times secant 3x. Now look, I'm very careful with my parentheses because this 2x is multiplied to the whole secant 3x function. So that's why I am making sure I'm using my brackets or parentheses, whatever, very, very carefully so that I don't make mistakes. The next one is x squared times the differential of secant 3x. Hopefully you guys are becoming more comfortable. Now remember, this is the outer function. 3x is the inner function. So according to the chain rule, you will take the differential of the outer function, which is what? Secant 3x times tangent 3x. Now this is the differential of the outer function times the differential of the inner function, which is 3x prime. So when you solve it further, this is x squared times secant 3x times tangent 3x times the differential of 3x is 3. The first part is already done. Now the last line is basically like writing it in a much more nicer mathematical manner. So you have 2x times secant 3x plus, get the 3 in the front because this 3 is multiplied to the whole expression. So it's a number 3 times x squared times secant 3x times tangent 3x. Okay, let's look at another example. Okay, y equals sine of 6x to the power 4. So notice there is an expression raised to the power 4. So when I take the derivative, that means first I will apply the general power rule. So here guys, here we have the general power rule first. Okay, that means you take the 4 outside, sine 6x to the power 3. And then you take the differential of the inside here, the sine 6x. Notice this is an expression very similar to what? We had, remember, y equals sine 7x? So this was the outer function, this was the inner function. So here you're going to apply a chain rule on it. So in this part, you are applying the chain rule. Okay, so the rest of the expressions remain the same. So it is 4 times sine 6's cube times, now the outside function differential of sine is what? Cosine, times 6x times the differential of the inner function 6x. Okay, then just do the differentials. You get the answer to be 4 sine 6x cubed times cosine 6x times 6. Then just make it much more nicer looking. Get the 6 in the front because it's all multiplication. It's 24 times sine 6x the whole cube times cosine 6x. Okay, let's look at a chain rule within a chain rule. So here this expression is a chain within a chain. So here we have y equals tangent of cosine of 2x. So the first time you apply the chain rule, you apply the outer function is tangent, the inner function is 2x. So here we're going to apply, remember, the chain rule. So if you find that, so you get secant squared. Remember the differential of tangent is what? Secant squared. So secant squared cosine 2x times the differential of the inner function the first time is cosine 2x differential. Now, so the next step, the first expression remains the same, which is secant squared cosine 2x. Now you look into the expression of cosine 2x. Once again, you have to apply a chain rule. So the outer function now is cosine, the inner function is 2x. So taking the differential of the outer function, that will be negative sine, and the inner function remains as it is, which is of 2x, times the differential of the inner function, which is 2x. So now when you do then you take the differential of 2x is a 2. So expression you get is secant squared cosine 2x times negative sine 2x times 2. Remember how careful I am with my brackets and parentheses. So you've got to be very careful too. Now take the negative and the 2 in the very front and write down the expression. You get negative 2 secant squared cosine 2x times sine 2x. Okay, let's look at things we have learned and practiced earlier. So we're going to start with that. Here, we're going to find the points where the graph of the function y equals x over square root of 2x minus 1 has a horizontal tangent line. Now remember, we've been practicing this for a pretty long time. So when you're finding points where the graph has a horizontal tangent line, it simply means find the points where y prime is 0. So the very first thing we're going to do is find y prime and then do the math and equate that to 0 to get the points. So let's go ahead, do the differential first. Now notice, this y is an x times square root of 2x minus 1. Now either you could apply the chain rule if you want, or you can do the quotient rule. I would prefer the quotient rule because it's going to make my life much more simpler. The reason is because if I take the square root and if you apply the quotient rule, the square root and the square will get cancelled out. So that's why I opted for a quotient rule. So the first thing I'm going to do is apply the quotient rule. There are many ways of doing it, guys. Whichever way you choose, make sure that you stick to it. So remember the quotient rule. That means if you have of y a function of u over v, then y prime is what? V squared u prime v minus v prime u. So your u is x and square root of 2x minus 1 is your v. So applying this quotient rule, you have x prime times square root of 2x minus 1 minus x times the differential of the denominator, which is square root 2x minus 1. And the square root of 2x minus 1, the whole square, is in the denominator. Okay, now we just have to do simple math. Differential of x prime is simply a 1. So you get a square root 2x minus 1 minus x. Now this, guys, remember we have done a simpler example in the first session, square root of a certain number. So this is the differential of 2x minus 1 to the power half. So we will get the half in the front. Here is the chain rule going to be applied, guys, now. The chain rule is going to be applied to this square root 2x minus 1. So what do you get? Half of 2x minus 1 to the power negative half. Now, the inner function is 2x minus 1. So you take the differential of 2x minus 1. What you get is expression square root of 2x minus 1 minus x times half times 2x minus 1 to the power negative half times 2. Okay? Now clearly, this 2 and this 2 can cancel out. Okay, let's see what we get. So, I've cancelled out the 2's here. You're left with square root 2x minus 1 minus x times 2x minus 1 to the power half. Now I can write it in a much more nicer manner. This one is negative half. I can write this as 1 over 2x minus 1 to the power half. Much more nicer looking. I write it as square root. And you will see why I have done it in the next slide. Because the question says, find the points where you have horizontal tangent line. What does that mean? It means find the points by putting y prime to be 0. Now remember, this is your y prime. If I have to put y prime to be 0, what does that mean? The numerator has to be 0. That's the real meaning of it. Okay, so notice here. So the numerator has to be 0. That doesn't matter what is in the denominator. So square root of 2x minus 1 minus x over square root of 2x minus 1 is 0. I can take the negative on the right hand side. And then square root of 2x minus 1 equals x over square root 2x minus 1. I have to solve for x. Do cross multiplication. X with 1, remember this is the same thing as saying square root of 2x minus 1 over 1. So x with 1 and square root with the square root basically cancels out a square root. That's why notice why I actually put this square root 2x minus 1 in the denominator. So what do I get? 2x minus 1 is x, or x is 1. And so what we have found is the graph of this function has a horizontal tangent line at x equal 1 alone. As usual, we're going to find the equation of a tangent lines. Now this is very important, guys. These kind of questions will be coming a lot in the exams as well as in your homeworks. So, find the equation of the tangent line to the graph of this function y equals cosine 3x at this point. Now remember, equation of a tangent line at a point is what? Y minus y1 equals m times x minus x1, where m is what? F prime of x. So the first thing we need to do is find the derivative of this function. Now this will be a chain rule. This is the outer function cosine in a function 3x. So the derivative of this function is minus 3 sine 3x. Remember, y is what? Cosine 3x. Clearly, it's a chain rule, so y prime is what? Negative sine, differential of cosine, keep the function, the argument as is there, times the derivative of 3x, which is what? Negative sine 3x times 3. Now this 3 has to come here. This 3 is not multiplied to 3x. Be very, very vigilant. So this is like this, guys. So it is minus, this 3 comes in the front, times sine 3x. So that's f prime of x. But remember, it's an equation of a tangent line. So that m at this point is basically, you're finding the value of this derivative at this point. Pi fourths and negative root 2 over 2. So when you substitute your x by pi 4, that is negative 3 times sine 3x. So basically f prime of pi fourth is what? Negative 3 sine of 3 pi fourths. And 3 pi fourths is square root 2 over 2. So it's negative 3 square root 2 over 2. Okay, so what is the equation of the tangent line at that point? Is given by this formula, y minus y1 equals m times x minus x1. You just substitute what you found for m. What is y1, what is x1, and that's your final answer, which is negative square root 2 over 2 plus minus 3 square root 2 over 2 times x minus pi fourths. Okay, now guys, if you remember, we have done higher order derivatives in our previous section. So we're going to apply this, now we're going to mix that with our chain rules. So find the second derivative of the following function. Y equals 4 over x plus 2 the whole cube. Now, there are two ways. You can either apply the quotient rule, or you can change it into an expression where x plus 2 goes in the numerator, and then you simply do chain rules. Either way, it will give you the same answer. There might be some computational involved. Okay. So let's do the first derivative. First derivative is what? It's in these problems, it's much more better to do the chain rule. You will realize as you practice more and more, you will come to realize, oh, I need to apply the quotient rule. Oh, no, I need to apply the chain rule here. And that way you will realize which one makes your life simpler. So always opt for a very simple way of looking at it. So what is the first derivative for this expression? It's minus 12 x plus 2 minus 3 minus 1, which is negative 4, times the differential of x plus 2. We all know the differential of x plus 2 is what? A 1. So which is basically negative 12 times x plus 2, which is negative 12 x plus 2 to the power negative 4. Now once again, if you take the differential of this is what? Negative 12 times negative 4 is 48. X plus 2 times minus 4 minus 1 minus 5 times the differential of x plus 2. Final answer, 48 times x plus 2 to the power minus 5. Okay, let's do some trig, guys. Now, y equals cosine x squared. I have done this problem before, so I'm just going to simply write down y prime. Now, y prime is negative 2x sine x squared, or was it? Oh, I think I had done y equals sine x squared, I think so. But this still is simple because this is, if you want to take the first derivative, notice what it is. Outside function is cosine, inside function is x squared. So your y prime would be the outside function negative sine, and it will be x squared times the differential of x squared, which is 2x. Now, make it in a nicer form, you get it like this. Okay, I think I've done it. Let me just recheck it. I think we have done it in some slides earlier. So it's, where was that slide? Ah, there it is. Yeah, so there is the slide, guys. We have done it earlier. So I was just going to make it confusing it, but no, we have done that example before, so we just need to go and pick it up from there. Y equals cosine x squared. Glad I remembered it. Okay, now we have to take the second derivative. So now this time, this function after the first derivative, it's a product of two functions, x with sine x squared. So we are going to do product rule now. Here is the product rule first. So it is 1 times the expression is 2. So 1 is x, the first function, second is sine x squared. So though you take the derivative of, now remember negative 2 is a constant, so you can take the derivative of negative 2, 2x as 1. So it's negative, then it's going to be negative 2x prime times sine x squared minus 2x, that's the first function, times the derivative of the second, sine x squared. Derivative of 2x is 2, so you get negative 2 sine x squared minus 2x as it is. Now here you're going to apply the chain rule. So this product rule is to this whole expression, guys. Let me say this one. Okay, so chain rule on sine x squared. What are we going to get? Now outside function is sine, inside function is x squared. So outside of sine, the derivative is cosine x squared times the derivative of x squared. That's this. And then finally when you solve it, what you get is negative 2 sine x squared minus 2x cosine x squared times the derivative of x squared is 2x. Now, as usual, I would like to write it in a much more nicer mathematical looking manner. So final answer, negative 2 sine x squared, negative 4x squared cosine x squared. So the final thing we always do when we have done a lot of examples is to practice these problems. So you have a lot of problems to practice with. Find the derivative of these functions. And then another slide, find the second derivative, and then you evaluate the second derivative at the point 0 and half. And the final function example problem is this function of g of x, where we have kind of done a similar kind of problem in our section 2-3. So make sure you go, if you have forgotten it, you can go ahead and look at that. So this is a composite functions here. So the only thing keep in mind, I just give you a little hint, is when you do h prime of x, it's now f prime of g of x times g prime of x. So that's what you have to do. We have done a similar kind in other sections when we did the product and the product rule, the quotient rule. We tried to apply a similar kind. We were given a graph and you tried to do those problems. So here we're going to apply the similar kind, but with now chain rule being applied to the composite functions. Okay, thank you guys.